Thanks, Nilgiri organizers for bringing me back here. I really enjoy this meeting because it's so interdisciplinary and brings in so many different points of views. So I'm going to not try and talk too much about what I spoke about last time. I'm primarily an ecologist. I study birds, and I've been working on birds for the last 25 years in the Shola ecosystem. And I'm based at this institute called ISAR Tirupati, which is a Ministry of Education institution. My primary connection with this landscape was through studying these birds, particularly the bird that was called as shortwing, and now we know it as sholakili or sholicola. And there's other group of birds called the laughing thrushes. So one thing that I want to kind of point out is that this group of birds are some of the oldest birds in the Western Ghats. So these are passerines, and they are on these mountain tops. And on the mountain tops, so they arrived here approximately 10 million years back from the Himalayas. And in the Western Ghats, they further speciated. So this is like your Darwin's finches. The one species came from the mainland, and then you have many different species. Similarly, here you have habitat islands, the Sky Islands, the mountain tops, and you have different species on these different mountains. And the divergence between the species, especially across the Palghat Gap, is really old. It's about 5 million years old. So some of these species have been here for a very long time. We heard a little bit about human history. Professor Sukumar threw in a little bit. Human evolution is about 2 million years or so, however you take it. Depends on different genera and Homo and stuff. But what I'm trying to say is that these birds have been here for a very long time. And I think it's the climate that is really driving these species. Another interesting thing is probably some of you recognize the species on the right. That's the Nilgiri Pipit. And on the left is the paddy field pipit. Both occur very close by in the Nilgiris. But what I've shown you here is the phylogenetic tree. And what that shows is that the Nilgiri pipit actually is a very ancient kind of branch from a group of birds about 7 million years back. Okay, so this very closely matches the forest bird, which I said is about 10 million years. So you have to think about this because now the other bird, the paddy field pipit, is fairly recent. The point that I'm trying to make is that there's a grassland bird that has been here for so many million years. So you can imagine that the habitat of forests and grasslands must have been there in some form. I mean, the extents may have varied at different points of time. So that's something to think about, that we've had these species for a long time. So it was I kind of got into this idea of invasive species just out of accident because I was looking for this bird to generate this data that you're seeing. And I went to Kodaikanal and I couldn't find the bird. And then I asked Bob and Tanya, who were restoration practitioners there, and they said, it's mostly all gone because the grasslands are not there. And then we said, then let's try and really map the habitats first so we can understand where the birds are. And that, along with Arundhati and other collaborators, got us to this path where we started looking at mapping the landscape. So for Nilgiris, you can see this is it's kind of, this is a GIF. You can see the years up there, 1973. And you can see how the red shade are timber plantations, okay? And the greens are, light green is the grassland and the dark green is the forest. And you can see that the invasive species, the timbers, are kind of moving further and further west. Yeah. What was interesting was the forests have been stable from this period of time. 1973 happens to be the first time when satellite imageries were available. So that was a starting point. So we've been able to kind of slice this data differently. However you look at it, I mean, basically the same pattern holds in many parts. Eriviculum, which has not had too much invasion, as you can see. Mukurti is kind of knocking on the door. I mean, it's almost there. And you saw images earlier from the DFO also. Kodaikanal is another story altogether because it's completely almost overrun by invasives. Uh, so this idea of having this kind of landscape, just forests and grasslands, that's actually quite challenging because what you see is a lot of invasives coming up everywhere. And why does that matter? I'll come to that in a little bit. But at this point, one of the things that we wanted to do was in the Nilgiris particularly, if you notice, a lot of the area by 1970s was already modified. So we wanted to get some historic perspective. And the way we did that was there was a student, Vijay Ramesh, who later did a postdoc as well, collaborative postdoc. And he worked with Amrita and a collaborator, Ian, who's going to speak next. And we put together this map of historic landscape change. And this is from Octorloni's map. And I think everybody is familiar with the name Octorloni. This was digitized. And this is the first cut that I'll show you. This was recently published just a month back. 1848, that's what the landscape looked like. I think the pointer is not very clear. But this yellow that you see, that's the grasslands back in 1848. And the 2018, you can see that the light green is the tea plantation, and that's of course understandable. But what's interesting is the grasslands gone down, but notice the forests. So forests have actually increased over this time. Okay, so it's not like there is no forest loss because some of the eastern parts you'll see that forests are gone. But in like the net area, forests have actually increased over this time. So this is something to note. In general, I mean, not expanding from the Shola habitat, forests seem to be doing okay. In terms of the area, what is underneath is a different matter. So I want to just highlight. So these are the maps. If you take a closer look, you can see how that's played out. The forest, in the western side, it's kind of increased as the small bits have kind of joined together, and then it's kind of become a larger patch. So that's really interesting. So what's the consequence? The grasslands have decreased, okay, by considerable amounts. And this matters because, so this figure is a slice of the Western Ghats, a bit like Pranay showed you. So you're looking at it from the side, and the elevation is on the y-axis. So if you're coming from the south to the north, you can see that the areas in the red, that's where this bird Nilgiri Pipit is found. That is only 1,800 meters and above. So you can imagine that maybe they were there in the other shorter mountains, but they are no longer there. So they are only in the highest mountains today. Okay. So you can imagine that with the grassland loss, this is quite a striking situation to be at. So this other student, Abhimanyu, actually did surveys across this landscape, and he found that large parts of Nilgiris and Anamalays have local extinction, which means that you don't find these birds in these areas anymore. Yeah. Nilgiris, particularly in the east, the eastern side of Nilgiris is quite striking. So there's another student, Jobin, who wanted to kind of, he was a landscape architect and comes from a different background. What he wanted to see was how does the changing vegetation actually impact these birds? And so this is the story that we've been saying, right? That there are these bits of forest patches and then grasslands, large grasslands, and then we planted invasive species, and that kind of has completely changed the matrix. So what's happening to these special birds that are in this landscape, both the forest birds and grassland? And that's what Jobin wanted to kind of find out. And there's been a lot of discussion of what's happening under the canopy. And of course, we know that even under some of these timber trees, you have both natural regeneration, native species regenerating, but you also have many secondary invasives under this. So we showed that eucalyptus actually has a lot of strong association with lantana, and this is work with Arundhati. So Jobin, what he did was quite spectacular because he did all these dots are his survey points. So he's actually covered the entire landscape where he laid both vegetation plots and looked for birds. So 1,204 plots across the landscape looking for all of these birds. And what he found was something really very interesting. So here's on the left, on the top left is the natural wooded habitat, which is like a shola. And you can see that, as you go from the wooded habitat edge towards this transformed wooded habitat, which is mostly the plantations, some of the endemic species, the specialists, actually drop down, as in their occurrence, they are still found, but their abundance is a little bit less, and that's mediated by the distance from the edge. So closer to the edge of the forest, it's almost functioning like a native forest, and these special birds are still there. But the story is very different when you come to open habitat birds, because open habitat birds, you can look at the transformed open habitat, which is your tea estates. And there you actually do not find these grassland birds. You don't find the habitat specialists as you go in. So that's a very sharp edge that you see as you go from grasslands. The point that I'm trying to make is that transformation of habitats, in some sense, is like a little bit like a yin and yang. Some species are certainly gaining from it. This I didn't talk about. There are some species that are expanded and have found more numbers in this habitat. So the question is always, what do we do now? The action points and where to restore. So we have previously, made maps of this. I spoke about this at the previous Nilgiri Scapes meeting as well, where we prioritize the landscape by priority 1, 2, and 3, which is based on the invasion stage. And priority 1 is the invasion front, where it's fairly easy to kind of clear and so on. But I think now I understand after the DFO's talk that the model of funding is that you want to target the large timber stands, because that's what is funding the restoration process. So anyway, in summary, all the maps of where restoration can be done, all the stage 1, 2, and 3 have already been given. And I was fortunate, along with Dr. Shankaraman here, to be on the High Court committee that was able to kind of pass this data on to the Forest Department. Just want to highlight that removal is not restoration. Everybody's been saying that, so I won't belabor that point. I want to end by just saying that the way of monitoring, actually, we have to really think a little bit more about. We had some discussion earlier about science versus conservation, but I think that the way to think about it is that now there is a lot of data, and data on where to restore is already there. It is actionable. Forest Department has it. Pretty much, it's there in the public domain. So that's actionable. But what happens next? So science needs to continuously engage with that process. And I think we need to generate more high quality data. And the problem is that some of these things are not very easy to pick. Like, single trees, you need very high resolution imageries to pick the young invasion and to map that. So I think that investing heavily in technology that can solve things at large scales. One of them is multi-spectral data, high resolution data. And another is something else that is very dear to me, which is bioacoustic monitoring, and where you can put up automated recorders and you can see what like birds and animals are kind of using the landscape over a long period of time. And what I mean is like over years. So do these birds come in only for a few days, or do they stay for a long time? All of this you can kind of gather information pretty easily, and it is scalable. You can put hundreds of recorders in the landscape if you had the intent. Yeah, thanks.